Okay, all right. Once again, my name is Ivan Rodriguez. I'm the Technical Programs Director for the Nkosi Canada chapter. And today's presentation is called Leveraging MBSE for Advanced Technology Development and IP, as in Intellectual Property Management. Our presenter is Dr. Shahram Pourazadi. I hope I pronounced that correctly.
Yes, correct.
Shahram is a technology entrepreneur and an IP specialist. So he has a Ph.D. in engineering science, working in the IP realm, building IP portfolios, commercialization strategies, and fostering growth for organizations. Dr. Pourazadi has led many patent applications and IP strategies across various industries. He's passionate about systematic product development, hence a wonderful presenter to have here for the system engineering technical program. And he's well acquainted with model-based technology management. Currently, Dr. Pourazadi is an IP consultant with Twelvivo. Did I say that correctly? Twelvivo Consulting, where he leverages model-based system engineering, or MBSE as we all know it, to enhance intellectual property and technology management for high-tech companies. So I'm hoping that, what we learned today, will help us all in our day-to-day work. With that, I'm going to turn it over to you, Shahram. So please feel free to share slides. And one last comment I'll make is that we'll allow Dr. Pourazadi to do his presentation. And please place your questions in the chat or save them till the end. And then I will moderate the questions. And/or if it's a small enough group, we can maybe just unmute as we go through the Q&A session. But without further ado, all yours, Dr. Pourazadi.
Thank you so much, Ivan. Sorry, Ivan or Ivan?
Yep, either one works.
Oh. Either one works. Thank you very much again for the great introduction. Again, my name is Shahram Pourazadi. Today, as Ivan mentioned, we are going to talk about a little bit about the benefit of leveraging or using MBSE, model-based systems engineering and advanced technology management, in particular, intellectual property management. So I would like to start with a little bit of primer on what is IP and what IP management could entail, and then go a little bit through what patents are and patent landscapes are and what's their role in technology management. And then I would like to go through how MBSE could be used to help with IP management. And throughout the presentation, I try to provide examples and case studies so that we could better relate to topics. So again, I work at Twelvivo. Currently, I'm a consultant at Twelvivo. We provide innovation advisory services, typically to high-tech or deep-tech startup companies or scale-up companies. My specialty right now is in intellectual property advice and consulting and technology management. And one of our unique propositions, compared to other consulting firms, is that when we approach intellectual property, we try and we pride in having a multi-pronged and a cohesive and a multi-pronged perspective toward IP, which does not include only the legal side of IP, but also include the technological side and the business sides of the intellectual property. So I worked with more than 30 tech startups and scale-ups in Canada and also globally in the US and other parts of the world. Here are some of the notable startups or technology companies that I've worked with. Most of these are Canadian-based. And are active either in the robotics, mining industry, chemical compositions, and they are really, what ties them all together is that they are highly innovative and technology or tech companies. So I know you all have heard about IP and intellectual property, but just for the sake of being complete and just to make sure that we are all on the same page, I would just mention some basics of what is IP. Intellectual property could be referred to patents, trade secrets, copyrights, trademarks. They are all different forms of what we call intellectual property. And intellectual property is really your genuine creation as a result of your intellectual activity. I just want to mention and focus that when we say IP or intellectual property, it does not just mean patents. Patent is just one form of the many forms or several forms of IP. Just want to make sure that when we say IP, there is a distinction between IP and patents. Patent is just a very special form of IP. But today, my main focus is going to be on patents. Just wanted to make that clarification that IP in general is much more than that. And when we say IP management, it doesn't just mean patents. It could also include trade secrets, intellectual property assets that are not ever published or are being tried to be kept secret. Most of them could be in documents. For example, the source code of a software is very confidential and should be kept a secret and should never be published at most cases. So source code of a software is also considered IP, but it's not patent, it's a trade secret. Or sometimes if we are talking about open source software or open source code, it's again a different type of IP. It's not a secret, it's published, but it's not a patent as well. So it's usually a different type of IP. In most cases, open source software are protected by the copyright law. And if you are in the software domain, you know that there are different copyright licenses, attached to different open source codes. So just wanted to make that clarification that IP is different from patents. Again, I think this is a good diagram that shows, where really IP is. IP is really, a perspective that requires a legal side or a legal knowledge or background. It requires a business knowledge, and it requires a knowledge in a science or technology domain. So IP is really, in order to tackle IP, we really need to know basic information in all three of these domains. Of course, some IP specialists or IP professionals are more comfortable or more educated on one of these fields. But when, for example, an IP lawyer, they have gone through legal educations to become a lawyer on IP. Of course, they are mainly focused on the legal side of it, and that's where they're most comfortable with. But they also need to have a good understanding of the business side of the IP, and they need to have a good understanding of the science and technology behind the IP as well. So one or more of these aspects or perspectives become more apparent or become more dominant in certain cases, but in general, IP is really the common area between these three fields. So just to mention bring up the importance of IP, I want to talk about a case study in which iRobot and their famous Roomba vacuum cleaners sued Shark because of patent infringement. So that really shows the importance of patents it could be used as a weapon for companies to prevent other or to exclude other competitors in the market from gaining market share, and also have provide them with a competitive advantage. So in this case, iRobot alleged that Shark is infringing some of the patents that iRobot had issued or granted. So looking at the lawsuit, you would see that there are a few patents that iRobot is alleging Shark is infringing. For example, these 5 patents were mentioned in the lawsuit, and what really each of these patents focus on are different, but they're all related to home vacuum cleaners. But for example, the first patent is focusing on the docking technology of the autonomous Roomba vacuum cleaner. The second one is on the side brush and some hardware features. The other one is related to cleaning zones and categorizing an area into different zones, and mapping features, and detecting carpet or floor from the rest of the other furnitures or areas. So although these are all related to autonomous cleaning robots, but they differ. And I'm sure that in the next slides, I'm going to go through a little bit of detail about what is really different in patents. So in order to do that, I just want to go through the anatomy of a patent. I'm not sure how how the audience in this presentation are familiar with patents. So please excuse me, please bear with me. I try to cover some basics of the of the topics, but in the same time, please feel free to jump in if something is not clear. Please ask your question, or if something is very obvious, I would appreciate if somebody, if Ivan, for example, if you could let me know that this is a very well-known topic. You don't need to go to the details, and you can feel free to cut me. So in this case, let's go through one of the patents by Roomba. A patent, as you can see here on the right-hand side, this is a cover page of a typical patent. The cover page has a patent number, when it was published, who are the inventors, what's the title of the patent, was it published before or not, what's the abstract. Usually there is a cover figure, but this is not the only figure that could be in the patent to describe the invention. But really what a patent is a document, is a written document with text and drawings to explain an invention, and also distinguishing a boundary of the technology that the invention is trying to draw for itself and try to claim. So a patent document includes an abstract, which is usually one paragraph, summarizing really a very, very brief, look at, what in high level, what the patent or what the invention is about. Then there is a summary of the invention and the detailed description in which, the drawings in a patent are being explained in detail, and different components of an invention is explained. And then the most important part, or the most legal part of the document, are the claims, where it's kind of like the bylaws of your apartment building, in which the patent document or the inventors or the owner of the patent is trying to set the boundary of the technology, that this is my idea, this portion is my idea, really. For example, a mobile robot with this particular sensor on top of it is really mine, or the way it docks to a charging station is really mine. So what is really the boundary of the technology or the invention is really being set in a very clear way in the claims. So if you want to understand the technology that is being claimed or described in an invention, in a patent, the claims is the sole or is the most important part that we should refer to understand the technology and its boundaries. I also want to mention that a patent document includes, citations, both backward citations and forward citations, which is a very important source of, source of information to understand the technology landscape around an invention. So for this particular patent, which was in one of the, in the lawsuit, this is one of the claims. I just want to show you and get you, more familiar with how the claims are structured, because this is where it really get tied into systems engineering. And just by looking at this claim, I hope, or I'm sure you will understand what's the relevance of claims with systematic thinking and systems engineering. That's really, where I want to focus to say, okay, this is where patents and systems engineering, get very close to each other. So in this case, this is a patent by iRobot that is trying to claim a technology for docking to a charging station. So the claim language says an autonomous cleaning robot comprising. So here we have an object or a system. It's an autonomous cleaning robot that includes an undercarriage, a motive system that is configured to do this function, an energy storage unit, like a battery, a base charging station, which is, is portrayed here in this picture, and a navigation control system configured to autonomously do this a few lines here. The first thing is to control the motive system to direct the cleaning robot about a room at a first velocity, control forward movement of the cleaning robot toward the base charging station at a second velocity, which is less than the first velocity, before completing a cleaning task in the room and in response to detecting a need to charge the energy storage unit. And then it goes on to say that stop the forward movement of the cleaning robot, to dock to the cleaning robot, and a few other things that I don't want to go through. But what I want to mention and focus on is that, the highlighted words here are objects that are being defined in this claim language. An autonomous cleaning robot, which is basically, if I want to have a picture in my mind about it, is this object here. And undercarriage, which is something underneath here. A motive system, a motion system, something that propels the undercarriage. It's a wheeled system, for example, but it doesn't say it's a wheeled system. It's using a more generic word, a motive system. Why? Because they want to set the boundary in a very broader way. They don't want to say it necessarily use wheels. It could be tracks. It could be, it could be hovering in the air. It could be levitated. So there could be a jet engine potentially. So they don't want to limit to just a few forms of propelling the undercarriage. So that's why they are using a broader term like a motive system. Energy storage units. base charging station. So these ones that are highlighted with the cyan color are really objects related to the autonomous cleaning robot. Of course, room here is an object which is environmental, is not systematic to our system. It's an environmental, but again, it's an object that our robot or our system is interacting with. And then there are some parameters here being introduced, a first velocity and a second velocity. So these are parameters associated with the robot. And then that are being defined here. Second velocity is slower or is lower, smaller than the first velocity. The first velocity is for cleaning purpose. Second velocity is for docking to the charging station. And then we have some, operational tasks or operational, concepts such as a cleaning task or a need to charge the energy storage unit. So these words that are being highlighted, if I want to have my systems engineering class, they are either objects or an operation or a process that are being defined. And what it tells me is that, and this structure of a claim is not unique to this patent. Whatever patent that you open and you read has the same structure. It starts with a series of things that are being defined, and they set the boundary of the invention that is being, described and being claimed. So that is where I think patents get tied to the systems engineering. Because the things and the objects are being defined here, and the relationship between these are also being defined here. An autonomous cleaning robot comprising these a few things. So these a few things are part of the autonomous cleaning robot. The first velocity and the second velocity are parameters of this autonomous cleaning robot. The navigational control system is configured to autonomously do these a few operations. So this is, as systems engineers, you can, very easily, I think you can try to map a system model in your mind to visualize or depict what this, this text is trying to say in a very systematic way. And that is where I try to get the, or leverage MBSE in my analysis. In my analysis, we need to do lots of patent readings. So going back to this case, let's assume I'm an IP advisor to Shark, and we are trying to commercialize our product, and then we are hit by a lawsuit by iRobot, in which these patents are being thrown at us, and we need to analyze this, and we really need to go through these patents and try to read their claims and really see if what we are being accused of is really correct or not. So we really need to go through the claim languages of each of these patents and then try to understand if we are within the bounds defined by these claims or not. And then having this systematic look and this model-driven systematic look at patents is very helpful when we are trying to compare our technology with what other people have been claiming. Any questions so far? I think I just want to hear some feedback from you if I'm going through too much details, or if people are engaging with this.
Yeah, there's no questions in the chat, Shahram, but I keep going. I think this is good, and I think you're explaining well what the system concern is here. So it's the system composition, right? The system architecture that we're considering here, and the system function. So yeah, please continue.
Perfect. Awesome. So then I want to go through a little bit of the tools that I use in order to, implement this model-based look at the claims or the patents or the technology landscape that these patents are claiming. So I personally use either OPM or Capella or a combination of both. Uh, Ivan, could you tell me if these tools have? I'm sure Capella. I know Capella has been discussed, but OPM has it been discussed, or should I go through more details of what is really OPM
No,
is? Object processing modeling.
we have had previous sessions on Capella, but not directly on OPM. So maybe just a brief overview.
Perfect. Perfect. Awesome. That's what I thought. So I have prepared some more slides on OPM, so I'll try to go through them. And I want to acknowledge that I'm going to be taking some of the contents, of course, contents by Dr. Christopher Cerquera. I hope that I'm mentioning his name correctly, but please check out his website at cscerquera.com.br. He's a professor in a Brazilian university. Um, I really took advantage of his course contents that are publicly available, and you can download them and go through them. So some of the slides or pictures that I'm going to show in the next slide, especially on OPM, are adopted or taken from his slides. So I just wanted to acknowledge that. So I really love this diagram because it shows just before going through what OPM is and what Arcadia is, which I know you know about, this kind of gives an idea of how I combine these two methodologies or these two tools in order to do analysis on patents. So OPM is usually used for concept modeling, and then Arcadia is usually more in a more depth level, engages a more in-depth level to do architecture modeling and really going through what are the requirements, what has been the operational conditions, and then the system characteristics, and then the logical and the physical characteristics. So Capella, I don't think there is, there is further discussions needed on this, but operational analysis, functional, non-functional needs, system analysis, logical architecture, and physical architecture are really, important when analyzing a single patent, because in a patent, as you could, as you could see, we had logical architecture components, we had physical architecture components, such as undercarriage, which is really a system or a component in the physical architecture. And we have something like a motive system, which is really on the logical architecture, rather than this claim going back here, really, instead of saying a wheel, which is a physical component, it says a motive system, which to me sounds like a logical component. Energy storage unit, again, it could be a logical component. Undercarriage, again, is true. It could be logical, it could be physical, and in fact, based on my experience, most of the components or the objects or the things that are being described or defined in a patent claim are in logical level, and the reason is that you don't want to have a very narrow claim. You don't want to say that, okay, I'm using lithium ion battery with this particular voltage. You generalize it. You tend to generalize it because you want to have a very broad claim. Your technology should be broad so that your technology is of more quality and has a more breadth and depth to it. So most of the words and things that are being defined in a patent claim are, to me and to my experience, are on logical architecture. And then there are a few things which are on operational and system level, such as when there is a need to charge the battery. So going back here, we have this thing here, or this item here, which is a need to charge the energy storage unit, or a cleaning task. These are really, to me, they sound things that are on the system level or on the operational level. And so this brings me back to the concept that when we try to visualize or try to create a model off of a claim language, Arcadia really is going to be helpful because it has a very systematic approach of how we can create a model. We have a paragraph or two paragraphs of text, and we can, if you're very familiar with Arcadia, it's not a very difficult job to map that text into the diagrams. And then I want to get into OPM a little bit more. So in OPM language, we have things, as the inventor of this language says. There are things. It could be either processes, which are are indicated with an oval shape. If they are informatical, like data or signals, they don't have a shadow. If they are physical objects, like an undercarriage, charging a battery, it's a process that has some physical meaning. So there is a shadow to it. And if it's an object, like a physical object, like a physical object, it's with indicated with a rectangle. It could be, if it's a physical object, it has a shadow. If it's an informatical object, there is no shadow. And the dashed lines identify things, either processes or objects that are environmental. They are not part of the system. They are part of the environment, such as the word room in the exemplary, claim, which is a physical environmental object. And if you want to show it in the OPM language, this is the right syntax to use. So here is an example of how OPM works. So Christopher, we have Christopher as an object, as a physical object. There is a shadow here. We have OPM theory. It's an informatic object. We have OPM tool, again, as an informatic object. We have presenting, which is a process, because there is a verb. It's a verb, it's a process, and it's a physical act. It's a physical process. And then we have presentation, which is an informatic object. And these are the lines that define relationships between these things. So Christopher is, and the good one thing that I forget to mention is that one good thing about OPM is that it also has a textual or a language attached to a model. So once you create this model here, this text is automatically generated by connecting Christopher to OPM theory with this particular line. This language is created automatically. So that's one thing beautiful about OPM that makes it easier to convert visual models into text. And that is very helpful for when we are analyzing patents, especially because patents are textual based documents. And this is going to save time and help us really with creating textual documents. So Christopher, this line is nose, or is defining a nose, a knowing relationship. So Christopher knows OPM theory. Christopher handles presenting. So this type of line means handling a process. OPM here, there is a consistency or a comprising relationship here. So OPM comprises of or consists of OPM theory. Presenting is physical. Presenting consumes OPM theory. So this line means consuming something. And then we have presenting yields presentation. So this process yields an object called presentation. So as briefly touched on, in OPM, we have different types of structural links. So relational links, aggregation, exhibition, specialization, instantiation. And then these are the syntaxes that are used for it. So examples are engine is attached to a gearbox. So this means a bidirectional, attachment. And then here we have aggregation, resource description framework statement, which is this object here, consists of subject, predicate, and an object. Exhibition, communicating, exhibits, interfering. Specialization, digital camera is a type of camera. Or if in the first slides I mentioned that patent is a type of IP. So here, if we had patent and here we had IP, this diagram was correct. And here we have instantiation. Jack Robinson is an instance of an adult. So this syntax is used to provide the instances of the objects. We also have procedural links, which are more related to processes rather than objects. So we have transforming relationships, enabling relationships, and invoking or invocation. And then, for examples are creating yields something or creating yields file. Editing affects the file. Deleting consumes the file. And here we have a welder handles welding, this process. A machine requires manufacturing. And here we have product finishing invokes product shipping. So once you are done with this process, it invokes this process. Or not once you're done, but this process, doing this process invokes this product shipping. We also have estates in OPM. So product is an object. The estates are indicated within an inside the rectangular shape of an object. So for example, this diagram here shows that product has two estates of not tested and tested. And we have a process which is testing process. And this process could change the state of the product from not tested to the tested status. We can have relationships or one-to-one mapping or one-to-many mappings between states and different objects. Here in this chart or this model, it says basically vehicle exhibits traveling medium. And in the traveling medium, we have the state, a ground state, an air state, and a water surface state. And the ground state is really related to a car. The air is related to aircraft, and water surface is related to ship. And all of these are instances of a vehicle or a specialization of a vehicle. One more thing about OPM is that it can handle complex systems by having zoom in and zoom out capabilities in the diagrams. For example, this one on the left is a higher level diagram that shows that we have a dishwashing process, we have a dishwasher object, we have a household user object, we have a soap object, and we have a dish set object. And this shows in high level what the system does and how they are connected together, but it doesn't hold much information. So if you want to go deeper and have more details about each of these objects, you can do something that is called in-zoomed option in the OPM. I can also show you later in one of the examples that I have. And in which once you click on the zoomed in version or in-zoomed version, you can see more details. So dishwashing includes further processes such as dish loading, detergent inserting, dish cleaning and drying, and dish unloading, and so on and so forth. So before going to, I want to switch gears a little bit and go to a different topic to do a case study of how OPM could be used to model patterns and to do technology mapping and technology studies and landscaping. Before that, I want to mention that the tool that is associated with OPM and you can do OPM modeling is called OPCAT. There is, as far as I know, there is a desktop version and an online version, cloud-based version. I personally use a desktop version, but both tools are great to use, very easy to use and learn. So yeah, switching gears a little bit from the case study that we had on robots and robotics, I think that case study, I really wanted to use that to introduce the topic of patents, how they are structured, what's the importance of them, how they are being used to commercialize products, how they are being used to prevent competitors from gaining market share or slowing down them to a certain extent. And also, I wanted to, with that example of the iRobot, I also wanted to mention the concept of technology landscape, where we have multiple technologies. It's not just one patent, we have a combination of patents that introduce a technology landscape such as home or autonomous vacuum cleaners for home, and where you have multiple technologies such as docking technology, such as detecting the carpet, such as doing zoning. So there are really multiple technologies. It's not just one technology, and that is what we refer to as a technology landscape or a technology ecosystem. So with that example, I try to introduce these concepts. And now with a different case study, I want to introduce how OPM or these modeling tools are being used to analyze patents and the patent landscape. So the topic that I have, that I personally worked on recently, not long ago, is the technology. The technology space is autonomy for open pit mining. And I want to show you two videos to get you more familiar with what open pit mining is, what are the machinery being used there. And then I try to pause in a few places in the video to tell you a little bit more about, what the technology landscape around autonomy for open pit mining could mean.
I think what you'll have to do, Shahram, is share. What I think when you shared your screen, there should be an option for sharing sound.
Okay.
So what you'll need to do is unshare, and then when you share again, there should be an option for sharing sound.
Yes, thank you very much.
Okay.
This nearly 100. We make Big Yellow Iron.
Oh, it seems that this.
And we're pretty good at
it.
And although you might
No,
not
we've
be in
got
the
audio.
market for a giant piece of
Do I have the
earth-moving
audio?
equipment, you may want to consider what this nearly
Sorry, did you say you have
100-year-old
the
company
audio?
has to say about technology. Why? Because of mining. Nearly every product you own, regardless of who makes it or what it does, would not exist as you know it without mining. And in the mining industry, CAT is the leading provider of big yellow mining machines and innovative technology, like autonomy. Caterpillar has been in the autonomy business for more than 30 years, and the results we've achieved aren't promises or forecasts. Our results are fleets of real machines doing real work on real mine sites all over the world. Really. No one is behind the wheel of CAT autonomous haul trucks, even when they're operating in the harshest environments on Earth. Plus, these trucks are big. The one you're looking at here is the CAT 797F autonomous haul truck.
So I want to pause here a little bit, and these machines are very complicated. They are very complex systems. You can see navigation systems such as GPS, and they are not just one. They are in definitely they are in communication with each other to determine, for example, their orientation, not just the location and position, but also the orientation. And there are so many different parts into this machine. Object detections, object avoidance or collision avoidance technology, navigation, path planning. These are some of the things that are on the soft side, and of course on the hardware side, there are so many actuators or sensors being involved, how they're being connected together to transfer data very smoothly, how to communicate with a cloud server or with a remote operator, how, for example, this machine has a wheel that is being controlled with a motor, with an actuator. So it's a very complicated system. In order to best communicate what the technology around this machine is, of course, systems engineering and model-based systems engineering is really one of the best ways to do that and to communicate the technologies involved in this very complex machine.
It's as large as a 2.5-story, 3,000 square foot house and weighs 284.6 tons, empty. When it's fully loaded, the CAT 797F clocks in at an impressive 687.5 tons, which is roughly the same weight as 15 standard 189-seat passenger planes. Since our autonomous mining trucks began operating commercially, they have now moved enough rock and earth to build a 4-lane dirt highway longer than the earth is round. That highway, though, would be 15 feet tall, and it's still growing. CAT autonomous trucks have now successfully moved billions of tons of material. That's right, with a B. That's enough to build a Hoover Dam over 3,000 times. So why does Caterpillar make autonomous vehicles? Because autonomy makes a big impact for customers who use it. It makes their mining operations more efficient. It cuts costs. It boosts productivity.
And again, here is something that I want to touch on is that we have some operational, needs or operational criteria or activities or objects that are really, when we are trying to create these machines or these systems or these solutions, improving 30% productivity is really what we would have in the operational level, and then tying up productivity to everything that we do, or what, as it's said here, reducing costs. So this is again another operational requirement, which when designing the solution or presenting the solution, this becomes very important in even in patents. When a solution is being described in the invention, the benefits or the advantages of the invention is really key and is really critical to be communicated as well. So having systems engineering in a systematic way or methodology such as Arcadia that has a very systematic way of tying different layers of problem and solution together is very helpful.
It cuts costs. It boosts productivity and profitability. But here's the stat our customers appreciate the most. CAT autonomous trucks have done all of that while working 24/7 on actual operating mine sites without a single lost time incident. Our technology leadership goes beyond autonomous trucks, though. We provide solutions that automate dozers, drills, underground loaders, and even trains. And the list is growing all the time.
Yeah, one more thing is that there is, in an open pit mine, there is not just one machine that is being, at work. There are multiple machines that need to work cohesively and concurrently together. You have a dozer here that is trying to pave the way for a loader or a shovel to then, excavate, and then a truck to, take out, the loads or the dirts away to a different location.
The time. We also provide advanced tech.
And sorry, this is really shows the complexity. We are not just dealing with a single complicated system. We are dealing multiple or a network of complicated systems. So it's a very complicated system that we are dealing with when we are trying to innovate or invent in one of these fields, or I mean around autonomy for open pit mining.
Technology that helps mining companies better manage, deploy, maintain, and adapt their fleets of mobile equipment. And many of these help keep people safe by tracking people when they're deep underground, using cameras and radar to let machines know when another vehicle is nearby, and alerting machine operators if they start falling asleep. There are a lot of reasons why Caterpillar has become a successful innovator. We have a global team of talented software developers and researchers, computer engineers, and data analysts. Every day they are making discoveries and working on new groundbreaking technologies. And they're fully supported by our continued investment in research and development, which is paid off with a growing portfolio of patents and intellectual properties. We also create partnerships with other best-in-class technology providers who add to our strengths and help us get our tech into the market more quickly. But
and as you can tell, IP and patents are a key part of innovating in these very complicated fields. There are long R&D periods and very expensive R&D periods, and companies who are active and innovating in these fields really want to have protection on the investment that they are making in the R&D and their commercialization efforts. So patents create a very critical role in not only protecting the inventions, but also in the way to commercialize these inventions, create competitive advantages, create moats for these businesses, and to foster relationships and partnerships. So a company who has patents is usually 30-40% more likely to be partnered with, because if for example I'm a company trying to optimize the operations of an open pit, and I know that Caterpillar has 14,000 active patents. So I really don't want to get into their space and technology space and infringe on their patents. So it would be more likely for me to work with them and collaborate with them and create a partnership.
we could always use more. More partners, more people filling opportunities in Caterpillar locations all over the world, and more potential solutions for our customers and everyone else. The advancements we have made in mining are already being used in other industries, but we are committed to remaining at the forefront and discovering so much more. And that, for us, is a promise that carries a lot of weight.
And then, so I hope that video gave you an overall picture of how autonomy, or what's the importance of autonomy in open pit mining. And here is just zooming in a little bit more on one particular interaction between machines and open pit mine. I want to focus on technologies that are particularly relevant to shovels and autonomous or shovels in general. These big machines do the excavation. They are called front-loading devices rather than the other, type of excavators or loaders, which are backward-facing toward their load. So these are front loaders, and they are huge machines. It's very difficult to operate them, and different sensors, different sensor technologies um, are very helpful, are being emerged to really help the operators avoid collisions, because these machines are really big and it's really hard to know where they are. You need to be a very experienced operator in order to avoid collisions between this deeper and the machine itself, or between this deeper and the truck when you're unloading. So it's really hard, or I mean, it's really the technology, new sensors, autonomy is being really helpful and being developed very rapidly to help operating these machines. First, we had technologies that are just on the monitoring side. As the technology is maturing and progressing, we had sensors which were enabling monitoring capabilities. And then we have control capabilities. We have semi-autonomous features, which kind of you do one repetition of the loading and unloading process, and then the rest is being done by the machine, by a controller. And then we have monitoring, we have control, and then we have full autonomy. So these are the three levels of maturity, going from all manual operations to all the way fully autonomous operations. In this industry, having a full autonomous, I mean, not having the full autonomous, but having semi-autonomous feature is very beneficial and very useful as well. So, and getting to the full autonomy is very challenging, very difficult, and needs a lot of reliable sensory data, very expensive equipment to make sure robust communications without delays or with a lot of redundancies. So with this video, the next video that I want to show you, I want to focus a little bit more on technologies around moving these shovels and moving loads from these shovels to a truck. So I want to, rather than continuing in the slides, I want to jump into the OpCat, which is the the tool for doing the modeling on OPM. I hope you don't mind that. So this is a version, a simpler version of, sorry. Let's see. Let me reshare again. Okay, so this is a simpler version of, one of the files or models that we created in order to better understand the landscape, the technology landscape, the patents that are being drafted in this area. In one of our studies, we identified more than 10,000 patents, unique patents and unique inventions on just how to operate shovels in a way that is more precise and in order to help operators be more productive and reduce costs. It not only include having autonomous shovels, but also include technologies for monitoring the operations of a shovel, for communicating or having better collaboration between a shovel and a truck, how to do a better control, a smoother control of the shovel deeper, technologies for localizing a shovel or localizing the tool or the head of the shovel. So there are so many thousands of patents really on different aspects of these complicated machines and the complicated interaction that they have with their environment and other machines. So we used OPM. So by the way, this is OPCAT. There is this environment allows you to create models. So here we have this informatical object, which is precision mining platform and management system. So this is our object, and it includes capability division. And the way we are categorizing this technology landscape is in two ways: a capability division, which includes monitoring, control, optimization, and autonomy. And then we have an asset or event agnostic or specific. So it could be asset agnostic, it could be asset specific. By asset, we mean the machine itself, whether it's a shovel or whether it's a truck or whether it's an excavator, because some inventions are particular to front loader shovels, but there are some technologies that is regardless of what machine it is. For example, a GPS technology that could be installed on any machine, doesn't matter, loaders, dozers, or trucks, it could work on any of them. So this was one of the ways we thought it's best to categorize the technology space. And then based on that, we try to dig deeper and see what the patents in this space are related to. There are some patents on the monitoring side, there are some patents on the control side, there are some patents on optimization, and some on autonomy. So here by the way, one good thing about OPM, as I mentioned before, is that it automatically, by creating this diagram, you are creating a textual representation of this model as well in a very systematic way. There is some delay, unfortunately, but for example, here it says precision mining platform and management system consists of capability division and assets/event agnostic. So it's really creating this language, and basically this really helps me in reporting as well. When I want to report my analysis with my coworkers or with my colleagues, then I can really take advantage of these text and create that report. So for the sake of this presentation, I want to go through patents that are related to the autonomy. So here, if I if I go zoom in, so this is the in-zoomed feature that I was talking about. So each of these objects, you could have further details behind them. So you can go to the in-zoomed version and see further details on it. So this is the in-zoomed version for autonomy. So in autonomy, we have decided that there are two other objects that are very related to the autonomy. There are some patents that talk about or focus on the machinery side and the hardware side, or really the machine itself. And there are some other patents that focus on the operations, either the operations of a machine or operations in the environment overall. So I want to focus on one of these, and let's go. And each of these boxes and objects here in green are individual patents. So this diagram really shows that, just by a look, shows that, okay, these 5 patents are related to both, side of the technology, and these not. These are more focused on machinery, and these are more focused on the operations. So each of these, in this model that we have, each of these patents are being modeled again. So if we go to in-zoom view, we can see more details about each of these individual patents. So in this patent, which is called, or it's titled, Autonomous Loading Shovel System, with this patent number, we can see that there are 3 independent claims in the patent. Each of these independent claims might be focusing on a slightly different aspect of the invention. But let's go to the first claim, and that's really where we can go to the in-depth and the details of what this patent is really about. So it just by looking at it, it gives me the idea that this patent is related to a processor for controlling an electric mining shovel. So this is the process. The controlling process is key in this patent, and also this processor is very key. This processor is very important. This processor is something you can imagine. It's like a microprocessor or a microcontroller that is doing a bunch of other processes in order for the overall goal of controlling this electric mining shovel. And the way we have created this diagram is by looking at the claim language of the patent, and then as I mentioned for the example of the iRobot, just identifying the objects inside the claim language and then trying to map it to the OPM language, and trying to draw the objects, draw the processes, and identify the relationship between them. And given the very structured language of the patent claims, it's not a very difficult job. It's a very straightforward job to map that textual document to this object or model-based diagram. So I think given the time, I think I was budgeting for around an hour. So I would stop here. I just want to summarize that patents are very important for protecting the inventions of companies, and to also direct research and development directions as well. The way we use MBSE, model-based system engineering, for IP or patent management and patent analysis is in 2 ways. We can use MBSE to understand a single patent, and not only to understand a single patent, but also to write a patent. Also, we could use it to understand a multitude of patents and try to get a sense of the technology space we are at.
Yeah, very good. Thank you very much, Dr. Pourazadi. Um, I very in particularly like the exposure to OPM, which I haven't used before, but it does look like a very good way to portray things. We don't have any questions in the chat, but I think we're a small enough group that if you do have a question, please just feel free to unmute and ask your question or make your comment. While we're waiting
Hey,
for
this is
somebody.
Devin.
Oh, there we go. I heard somebody. Go ahead.
Hi, this is Devin Hall here. This is very interesting. First of all, thank you for presenting.
Of course.
Have you seen one of your clients used this framework for innovation as well? So maybe drawing up this framework like you have here and identifying areas where maybe you have patent gaps, like maybe where you want to direct innovation. Is that something you've seen as well?
Yes, absolutely. Great point. Thank you very much. That's one of the very important aspects or benefits of using MBSE is to identify the gaps where when we do, one of the purposes of doing technology landscaping in general is to understand what other people or other companies have patented and then trying to understand the gaps. And when we have thousands of patents in a space, it's really hard to see those gaps, really hard, very, very difficult. Of course, there are patent analytics tools, which are mainly textual and by keyword search or by different other types of textual based or conceptual based analysis. You try to narrow down your search to maybe 40, 50 patents, and then within those try to understand the gaps. But using a visual way such as MBSE is a different level of identifying the gaps. And yes, if there have been a few clients who have been interested and who have been using or we have helped them actually take advantage of MBSE to identify the gaps in the space and then try to adjust their innovation or R&D efforts to address those gaps.
Shahram,
Great, thank you.
Shahram, is this convention, is this accepted in law? So can you portray your patent in this form, or do you need to then convert this to words for the claim itself?
Yeah, I haven't, to the best of my knowledge, the convention is still textual based. So in courts, so in case of, for example, Roomba versus Shark, Shark litigated against iRobot, claiming that, well, these are allegations that I'm being accused of. In fact, I'm doing things differently from your patent. And to do that, they need to do everything or most of the things in textual base. And we have things like claim charts, where it's basically like a table that you put your product and what it does in different rows of the table, and then you put the claims of your competitor in the rows in front of it, and you say, well, you see, they are doing these 5 things. I'm just doing 2 of it, so I'm not that. And so it's really textual based to the best of my knowledge. But in order to get to those textual based, having this visual, we have leveraged this tool to get to those textual based analysis or responses, and then those textual based are presented to the legal officials.
Okay, yeah, and per the last question or the response to the last question, if you identify any gaps, then you know that you have a full and complete claim. If you don't do it this way, you may have to live with that risk that there's a gap and you're missing something, and whoever you feel has violated your patent may be able to defend themselves.
Exactly. That's exactly right.
Mhm. Now, what about that said? Now, what about the reverse engineering aspect? If you are, for example, the use case with Shark and iRobot, if like Shark surely knew that they were developing something similar, could they use this technique to develop something and stay just on the line of not violating the patent?
Uh, Potentially, yes. If usually companies, especially companies who do a lot, spend a lot of or invest a lot on their R&D, and they want to be bold on their product release, they beforehand they try to be proactive and do an analysis of their competitors' patent
Yes.
portfolio. And as you said, they try to see, okay, where is the line,
Where is the line?
how far we can go. And there are some technologies that are publicly available and or known or best practices, so everybody can do it. Nobody can have exclusive rights on them because they're either old or they are being publicly disclosed or public knowledge. But using this MBSE tool is definitely, my personal experience has with my clients have been that it really helps in visualizing and not just visualizing but communicating this differentiators and these boundaries. you know Text-based documents are sometimes open to interpretations and sometimes hard to understand, especially if there's a legal language involved, whereas with visual language it's easier to understand and identify.
Okay. Now you've mentioned environment, process, and object. And for the most part, I think we gravitate to object for patents and patent infringement. What about not object but process? Is that patentable? And do you have any experience in that realm?
Yes, absolutely. So let me actually go back to my slides.
Mhm.
So I don't know if you can still see my slides here.
Yes, we can.
Perfect. So let me actually go to this Roomba patent, and because they have claims on not only objects and physical system, but also on a methodology or a process
Okay.
as well.
Yes, good.
So, oops. So yeah, this is Google Patents. Just by typing a patent number in the search bar, you can bring up a patent. It has the metadata information about the patent, and also if you scroll down a little bit, here are the claims, and there are 26 claims, and the first claim is actually a method claim.
I see.
So here it says, it doesn't say my claim is a cleaning robot. It does not say that. It says it's a method of docking a robotic cleaning device with a base station. So it's a process. So if I want to do that with the OPM, I should draw an oval and say,
Right.
okay, it's we have a thing which is docking robotic cleaning device with a base station. Of course, I'm going to right away go and create their objects as well, because it's kind of implying that there is a base station and there is a cleaning robot here. So there are two objects, but the main thing here is a docking method.
Yes. Very good. Thank you.
And if I actually go back here, the main, for this particular example, this is the case as well. So for this patent, the main claim is a methodology, is a method for controlling an electric shovel.
Right.
Using a processor that does this bunch of things, determining a profile of a digging surface, identifying a predetermined bank profile, and doing these really processes, not objects.
Yes. Good. Thank you.
I don't know if I answered your question. Was it directed to the same topic or?
Oh, yes, exactly. That is what I was asking. Thank you.
Perfect.
We are over time, but if there's another question, I think it'd be great to take it. Anybody have any further questions or comments?
Hi, Ivan. I have another question for Shahram. This is
Hi,
Arman
Arman.
from Canada Chapter Board. Very good presentation, Shahram. That's very informative. Thank you for
Thank you.
sharing experiences and examples. So my question is that you talk about two software, Capella and then OPM. And then you shared a slide about the MBSE methodology. My question is that did you find any specific methodology more helpful when it comes to patent and IP area for the application of MBSE?
Yes,
And then
great question.
second question is about AI. Have you used or do you have any experience using AI with the MBSE?
Great questions. The first thing, I really like this, diagram here. OPM is really, as Dr. Christopher Sercura, puts it, it's very good for concept modeling, and Capella Arcadia is very good at going to details and architecture modeling. So I have used a combination of both, but in most cases that I'm using MBSE, I stop at OPM level because patents, especially if, okay, here is the thing. If the purpose is to understand other people's inventions, and trying to have an understanding of technology landscape, OPM should be sufficient. But if you are doing your own invention, you have products, you want to make sure that you're protecting different aspects of your product, a combination of both, in my opinion, is needed. You need to have Arcadia as well in order to really tie your components, your physical elements, your logical elements, all the way to the requirements and the benefits. And for the second question, sorry, I forgot your second question.
Yeah, it was mostly about AI.
AI, yes.
An application of that in MBSE specifically for the patent application.
We have used the closest case that we have had. I don't see any problem not using MBSE for AI. Usually AI patents are related to computer elements. There should be a computer element to it. For example, unfortunately, I don't have an example here ready, but examples are numerous. There are lots of software patents that could be modeled very easily with OPM or Arcadia. And AI patents are usually about a computer implemented methodology where you have, for example, OpenAI. OpenAI, I was reading one of their patents a few days ago, and they have a patent that says we have a user interface in which there is a picture, a user can upload a picture and can select a portion of that picture. For example, it's a dog with, a few plants and flowers behind it. So if a person clicks on one of the flowers at the back of the dog and ask a question about it, write a prompt about it, that, can you tell me what this is, this flower is, what's the type of it, can you tell me how it's interacting with the dog? So any prompt, the OpenAI in the backend do something to respond to that prompt. So that methodology or that computer system, that there is a user interface, very particular way to select items on the images, and then having a server at the backend that receives a prompt and then do some analysis with LLM, large language models, and then prints out a response. That procedure is really the first claim and the first topic of that patent. So there you can definitely use MBSE to model or to analyze patents for AI. And the closest I've been to to use OPM. I've actually used OPM for an enterprise data analytics software. So a software that has been used to analyze the data from multiple chain stores, for example, Walmart, the transactions of the customers, the customer behaviors. So I've actually used OPM to analyze the patents that are in the space, trying to make the data analytics or the enterprise data analytics more efficient, how to visualize the data, how to process them, the data pipelines that are used to do that. So yeah, it's a very complicated thing to do, because the concepts are very abstract when it gets to software, but it's definitely doable.
Great, thank you, Shahram. Appreciate it. Very helpful.
Of course.
Very good. Thank you. One last call for questions. Going once. Going twice. Okay. Well, thank you, Dr. Pourazadi. I enjoyed this talk. I'm sure everybody else did. We appreciate it. And I know there will be many that will be watching the recording. That recording will be available probably in about a week's time on the NCOSI Canada chapter website. Yeah, and just to like to close there, and I'm going to stop the recording, and thank you one last time.
Amazing. It was a pleasure. Thank you for the opportunity to give that, give this presentation, and thank you very much. And feel free to, I want to invite everybody who have further questions or follow-up questions to do not hesitate to reach out to me, and let's chat about how we can take advantage of MBSE in managing intellectual property and technology.
Wonderful. Thank you to all of our attendees as well. Take care.
Thank
Bye,
you.
everybody.
Bye.